Record. Okay, so we're going to start with chemical rockets. Chemical rockets. There are three basic types of chemical rockets. We have talked significantly about two of these types. What are those types? Solids and liquids.
But there's ion.
We'll talk about ion. We'll talk about hybrid.
Oh, there's four rockets.
Oh no, there's more, buddy. We'll talk about more. Okay, so types of propulsion. So chemical rockets are the ones that we have talked about the most. Remember that the main engines on the space shuttle were liquid fuel. They burned so you're ruining my YouTube content. Okay, so I know you don't have to make it an announcer voice. It's time for living. Okay, so liquid rockets, liquid fuel rockets, like the main engines on the space shuttle, these you can use different fuels. Okay. Use different fuels on liquid rockets. So for instance, in the space shuttle, they used hydrogen and oxygen, right? Hydrogen and oxygen, which is definitely not the way that you spell that. Okay. So let me pull this up here, make the text box, make the text box bigger and longer. Jamboard. Okay, so liquid rocket. Liquid, let's do liquid fuel. Liquid fuel. Yes.
Are we going to learn about that?
We'll talk a little bit. Okay. So when we talk about liquid fuel rocket engines,
What are the three types of
well,
rockets?
chemical, liquid,
Solid.
solid, hybrid.
What?
Hybrid. Okay, so liquid fuel rocket engines, let's make this just a little bit longer, there we go. So fuel types. Types. We can have hydrogen, which is like the space shuttle. Space shuttle.
Do they all use oxygen?
Not all of them. And we'll talk about that in just a second. You can use kerosene. Kerosene, which is essentially just highly refined jet fuel.
There's also highly refined kerosene.
Yes, the Saturn rockets, the Falcon rockets use kerosene. Okay, so the Saturn V, the Saturn 1B, the Falcon 9, the Falcon Heavy all use kerosene.
And that was oxygen too.
So yeah, they use liquid oxygen as the oxidizer for these. And you can usually assume that they're going to use liquid oxygen as the oxidizer just because it's the most efficient. But you can use other stuff, and we'll talk about that with hypergolic fuels in just a second. You can also use methane. There has never been a functional operational launch vehicle that uses methane. The only methane liquid rocket engine to ever fire and actually fly something into the sky, not into space, but into the sky, is the Starship.
Oh, that's just kind of, well, then again, it's kind of a flex move if it actually works. Didn't use nothing.
Yeah, so
Like, we use the power of the cow.
methane is kind of the holy grail of liquid rocket fuels.
But it hasn't worked.
It hasn't really worked very well so far. Why? Because it has to be at an insanely high chamber pressure. We're talking 300 atmospheres of pressure. The space shuttle main engines operated at like 190 atmospheres.
It's such a variable. Like if you lose pressure in the chamber while like on the stuff, it just fails.
Yeah, but the thing about methane is it's efficient. It's more efficient than kerosene, but it's better to store, easier to store than hydrogen. Hydrogen is very efficient, but it is extremely difficult to store, and the tanks that you use for it have to be enormous. Okay?
So what has the source of the using on step one?
It's been using methane.
So it has one.
It has worked, but they haven't gone into space.
Okay. Oh, so in order to make it work in space, it has to be that pressure.
No, in order to make it work at all, it has to be at that pressure.
They didn't manage to.
They can get it to work, but they haven't gotten it up into space yet. We're just doing test flights. American Sign Language. Okay. So these are the most common. Kerosene is by far the most common. I can name just off the top of my head probably 4 more rockets that use kerosene. The Electron, the Soyuz, the PSLV and GSLV from India, the H2A, the Japanese rockets. I'm trying to remember if they use kerosene or hydrogen. Anyway, those are the most common ones. Okay. So these are, and all of these use, I think this is a little bit smaller, but over here. All of these use liquid oxygen generally as oxidizer. Okay.
So is this an exhaustive list, or is this the most common?
These are the most common. This will not be an exhaustive list. We will talk about, I mean, this will be the most complete list that you've seen in terms of types of propulsion in rockets. Yes, Bill? It provides the oxygen for kablooies. Because remember, if you use it like a jet engine, if you use a jet engine in atmosphere, you can just pull the air into the jet and the air has oxygen to burn things. But because we're going to space, there ain't no, we need oxygen, we need to bring oxygen with us in order to be able to create thrust in space. Yeah.
Can you make like something where like the first stage is like an airplane that just uses the air from the space around us, and then once it gets high enough, it'll like shed off, and then they'll use like actual engine, and then they'll use
So there's a couple ways you can do this. Yes. So Sam, if you didn't hear the question, could you use an air-breathing engine to get up into the atmosphere and then launch from there? Yes. The Virgin Orbit Launcher 1 does that exact thing. It uses a 747 to get into the atmosphere, and then it is carried under the left wing of this 747. Then it drops off, and then it ignites its engine. This is a hybrid engine. Wait, no, this is a liquid engine. This uses kerosene as well. We'll talk about hybrid engines in just a second. But then once they get, I think they launched this thing at like 20,000 feet, something like this. So it's already going forward and it's already kind of high up. The thing is that jet engines can get you going relatively fast, but not I'm going to space fast. To get going fast enough to get into space, you either have to use a ramjet, which only works at hypersonic velocities anyway.
It's time for student government to come on down to their school photos to the council's office. Student government, start getting out for Mr. Kershaw.
Why do you know this?
Who's this?
Why do you know that I'm annoyed at you?
There's the imposter.
Who told?
Quinn has found out somehow. Okay, anyway.
I don't get how Word was able to travel out of this section.
It was probably from chemistry. Let's be honest. It was probably from the chemistry people. Elijah,
You never mentioned that you were going to chemistry.
I didn't.
You were going now.
you can probably just see it on my face and I'm annoyed. Okay. So yes, you can use an air-breathing engine to kind of kickstart yourself, like the Launcher One does off of the. This is a 747. This is a perfect name, by the way. This 747 was given this name before it was assigned to be the platform for the Launcher One. This is the 747 named Cosmic Girl. Virgin Orbit. So Virgin is the company, right? So Virgin Airlines owned this, and then they started a space launch company called Virgin Orbit. They also have a space tourism company called Virgin Galactic, which we will talk about later. Sir Richard Branson.
Cosmic Girl is so great.
Cosmic Girl, yes. Okay.
What does the inside look like? Is it stripped out hollow, or
Yeah.
do they also like provide public transportation to like check out the launch?
So this used to be a normal 747, but they've stripped everything out of it. It was retired from their fleet of like passenger planes, and then they were like, hey, we got this 747. And 747s were actually designed to carry a really heavy payload under the left wing. They designed it to actually carry an extra engine.
So it's not carrying it in the sense that it's carrying it on the left wing,
It carries it under the left wing. Nope,
but it was designed to
it was designed that way.
on the left. That's pretty cool.
Yeah, it was designed to be able to carry an extra engine to transport for like maintenance and so forth.
So how do they count the weight? They had to put like dead weight on the other.
So you can put extra fuel in the right wing. So the wings are essentially just wing-shaped fuel tanks in most planes. Yep. Okay. So, okay. So yes, you can use an air-breathing engine to get up in the atmosphere and then launch from there. So when we talk about look. I'm just gonna pick up the all call and be like, stop it. Okay. So those are the happy-go-lucky versions of liquid rocket engines. Let's talk about the less happy-go-lucky versions of liquid rocket engines. Liquid fuel rocket engines. There we go. Let's talk about hypergolic.
So this is possible to do?
Yep. Hypergolic fuels. So a hypergolic fuel, so in chemistry, when you say something is hypergolic, it means that when it touches this other thing, it instantly goes boom. Okay? These previous ones all require, not only do they require oxidizer, they require an ignition source.
So that means that the hypergolic ones have oxygen in the molecules themselves.
Yes. source. Require an ignition source because you can flow methane and oxygen into one area, but without an ignition source, they won't light.
So it is hypergolic.
Hypergolic means once the two substances touch each other, they instantly explode. Okay? There are a few different types. These are still liquids. Yeah, these are not the ones that we just covered. These are different kinds of hypergolic fuels. Oh.
This is not required that oxygen is fuel source.
So you need fuel and you need an oxidizer, but the thing is that in this case, the fuel and the oxidizer instantly explode when they touch each other. So examples of these would be, and these are scary words if you haven't taken chemistry. Nitrogen, tetroxide, plus hydrogen, plus hydrazine, and then I'm not even gonna write out this entire name. It's monomethylhydrazine and unsymmetrical dimethylhydrazine. It's just it's abbreviated as MMH, monomethylhydrazine. These explode on contact. With each other. They will also kill you in a lot of very unpleasant ways.
So if I drink the nitrogen peroxide and then I drink hydrogen, I would blow up.
Yes, well, you wouldn't make it to the second step. If you tried to drink dinitrogen tetroxide, you would already die. Why did I pick today to record? Why? Okay.
Oh yeah, I know what TikTok things now. Yeah.
Aiden. Nope. Still no. Both of these will kill you. Oh, well, all of these will kill you.
What is it like?
Like pretty much instantly. This is.
What if something bad for my dead body?
So this is the way that you have to deal with hypergolic fuels.
So even if it touches you, you die.
If it touches you in small enough amounts, you'll just die of cancer in a few years. It's not radioactive. It's carcinogen. It changes your DNA.
It's a superhero that.
Sure.
Oh my god, we're gonna turn into superhero like for kids. He's just stuff. He's not break the stuff. Alright. That's a little far.
Yeah. We've turned the space exploration into let's become superheroes class. How are these made? That's an excellent question. I do not know the answer to.
But they don't just appear in nature.
No. They're so reactive that they would not be stable enough to just be hanging out anywhere.
That's what I thought.
Yeah. So this guy, back in the day, you might recall the name Sergei Korolyov, right? The primary engineer for the Soviet rocket program. he had kind of like a guy, kind of a rival, but they worked together, that was in charge of propulsion. His name was Valentin Glushko. Glushko was a big fan of hypergolic fuels. He liked that you didn't have to have an ignition source. They were very reliable. If you just flow the thing into the thing and they touch each other, it goes boom.
And this Lucio guy probably died.
Oh, I mean, he did die eventually. I don't know how he died.
I thought fuel was meant to
Yeah, no, he survived to an old age. He died at the age of 80. But these guys, anyway, yeah, hypergolic fuels. They're pretty nasty. They will kill you, okay? Most space programs do not use hypergolic fuels, at least for their launch vehicles. Some use hypergolic fuels in like satellites and other things that go out into space because they're really reliable. For instance, the engine, the ascent engine on the lunar module that got the astronauts off the surface of the moon used hypergolic fuel. They wanted to make sure that it worked. So they use hypergolic fuels. The only country that currently uses hypergolic fuels in their launch vehicles that actually like use them here in the atmosphere is China. Okay. All right. So that's liquid fuel. Let's look really quickly at how liquid fuel engines work. What?
When we took off to the moon, did we have a backup crew ready to launch if like it became stranded?
Nope.
Okay. The race is that high.
The president did have an address ready to say, the men that went to the moon in peace will stay in the moon in peace. Will rest on the moon in peace, I believe is the way that he phrased it. He actually already recorded it. Richard Nixon recorded this message that was supposed to be sent out if they landed on the moon but couldn't get off.
Do we have recordings of this?
Yeah, you can look it up. Okay. Liquid rocket engines. This is a super simplified version. You have the fuel tank, you have the oxidizer tank, you have some turbo pumps. The pumps pump the material from the tanks into the combustion chamber. Combustion chamber, again, you need, unless it's a hypergolic, you need an ignition source. Then it combusts in here, gets accelerated through the throat of the combustion chamber, and then gets shot out the back. When it shoots out the back like that at really high velocities, it's essentially pushing on the walls of the bell of the nozzle, because it pushes on that in all directions. They flare it out like that so that it pushes forward.
Now, besides the fact that we're seeing electrically controlled wires, why can it not be as simple as
It can be if you want it to be super inefficient. And I mean, this thing right here that it says pump, these pumps have thousands of parts. The majority of making a really good liquid rocket engine is making good turbo pumps. These things, I mean, the turbo pump, imagine the turbo pump for the F1 engine on the Saturn V. Okay? Remember how much fuel the Saturn V went through every second? Does anyone recall?
I remember being astonished at it, but I don't remember what was it.
Wasn't it like 10 gallons per second?
No,
No, it was like 1,000.
Oh, no, it was a ton. It's 2 tons.
more. 3,000 gallons per second.
Yeah. That sounds about right.
Okay.
Yeah, again, now I'm astonished. Now,
So this is a J2, which was the upper stage engine of the Saturn V. This was doing a few hundred gallons per second. These pumps are going real fast. Okay. This is a stripped down version of what it looks like. They've gotten rid of like a lot of the piping and stuff like that. Not only do you have to make the combustion, but you also have to keep the nozzle cool, which is a problem. You also have to keep all of this from just exploding, right? You have to be able to make it strong enough that it can withstand the pressure inside the combustion chamber. These are very, very serious very serious endeavors. Okay, let's check this one out. Let's see here.
So what solution did they come up with to keep the nozzle cool?
In this case, you see these ribs.
Yeah.
They actually flow liquid oxygen through these pipes, these little pipes, before it goes to the main pump.
So it cools the nozzle as it's being used in the fuel.
Yes. So the liquid oxygen is piped through these little tubes to keep the nozzle cool while the combustion is happening. This is the Raptor liquid fuel rocket engine. This is the Starship.
This one doesn't have ribs.
It is not. It does not. So this is cooled through, oh, I'm trying to remember, a different process. I cannot recall the way that they cool these nozzles.
When it launched, because the guy was sitting on the engine and he just sprays it for water.
So this is just a 3D model here. You see all these little pipes, and then here's the vector control system that like pulls it in different directions. Yeah, I mean there is a lot of engineering that goes into these things. So you can see, I mean, look at how complex that is. All these wires and tubes going everywhere. Yeah, this is an F1. No, this is not an F1. This is an RS-25. This is a space shuttle main engine. Gigantic boys. Yeah, the space shuttle had 3 of these. Human for scale.
Is that an adult? Or?
Yeah, that's an adult woman. Probably, I don't know, 1.5 meters, something like that. Like, a little shorter than me.
She's 3 foot 2.
Yeah,
I doubt that. Okay. So, yeah. One more picture here, just to kind of drive home that the point. Okay. So we've looked at all these different engines and how complex they are. If you want to learn more about, there are different kinds of liquid rocket engines, like different cycles. So the way that you get power to turn the pumps can be different. For instance, the Electron rocket. This is kind of fun. The Rutherford engine. Who did their launch vehicle report on the Electron in here? A few of you. So you may recall that The engine for the Electron, the Rutherford, is kind of special. First of all, this entire portion is 3D printed, which is cool.
How does it, man?
All these pipes are 3D printed.
How does it survive with heat? 3D printed like plastic.
So the Electron launch vehicle has been launching since 2016, using the Rutherford, 2016 or 2017. This right here is the turbo pump. It is a brushless electric motor.
Don't that use like magnets or something?
So yeah, well, yeah, and if it's electric motor, it has to use magnets.
And what do you mean by brushless?
So it's essentially the same kind of electric motor that you'd find in an electric car, electric vehicle. This thing can go at several thousand RPMs, right? And they use batteries. They use batteries to fuel it. You know, lithium polymer batteries, which are pretty cool.
So do you know what kind of alloys they use for the metal?
I think that this is an alloy of titanium, actually. I'd have to look it up.
Why do the combustion chamber so big compared to the?
So this is actually a really small little engine. They use 9 of these. They use 9 of these on the first stage of the Electron. Here's the oxidizer, and then the fuel lines. You can see there's small lines going through here as well. That's me. Okay, just a second.
Oh,
Tark, yeah. Just a second. Let me pull something up. Rocket engine. I'll be back. Just a second. There we go. There.
It's distracting things.
Wait, what? What's happening?
Of things that Kerbal Space Program doesn't teach you. Today, I kind of want to talk about the plumbing that goes into making the rocket engines work. I mean, rocket engines are really all about the plumbing that takes the fuel from the tanks and into the engines. But anyway, this week we've of course had Elon Musk giving his SpaceX Mars presentation, and yeah, a lot of people were super excited about it. The news people loved it, but the real rocket scientists, they were paying more attention to the Raptor engine, which had apparently been tested a couple of days prior to this presentation. Now, Raptor is going to be SpaceX's next generation engine, and the stats, the performance stats that they want to achieve on this thing are amazing. The chamber pressure is going to be 300 bar. The thrust is going to be something like 60% that of an F1. It runs on the fuel of the future, that is liquid oxygen and liquid methane. And somewhere down in the small print, you might have seen that it's a full flow staged combustion cycle. Now, if you're not a rocket scientist, you probably know what each of those words means on its own, but together you probably come up with a blank, and that's what this episode is all about. So we're going to rewind and start with something simpler. In Kerbal Space Program, you basically take a fuel and oxidizer engine and you attach an engine to it, and the fuel magically flows into the rocket engine and makes it work. But in reality, you kind of need to make the thing work according to physics. The simplest rocket engines, you have a fuel tank, you have your oxidizer tank, and you just pressurize them with some gas. Typically, it's an inert gas like nitrogen or helium. Helium is by far the most common. And if the gas pressure is high enough, it forces the fuel out of the bottom of the tank through the plumbing and into the engine. Depending upon the design, you may have a pressure-rent tank, which has to perhaps run its fuel over a heat exchanger around the engine to replenish the pressure that's lost, or sorry, as more space comes into the tank, you need to fill it up with more pressurizing fluid. But really, it's a very, very simple process. And turning these engines on typically is done by just opening a bunch of valves and then closing a bunch of valves, especially if the fuel and oxidizer are hypergolic. Pressure-fed engines are used whenever you need engines to be really reliable and always work. They're used in reaction control thrusters. The Apollo, all the Apollo lander engines, the AJ-10 upper stage, and the maneuvering engine or orbital maneuvering system on the space shuttle. Very, very simple, but it has its limits. One of the things about this is if you want to get high thrust, you need to have high chamber pressures. If you want high chamber pressures, it means you need high fuel pressures, and that means you need high tank pressures. And if you want high tank pressures, you need to have very, very strong tanks, otherwise the tanks will burst. If you want to know what happens when a fuel tank bursts, take a look at the two SpaceX failures. Although they don't use pressure-fed engines, they still pressurize their tanks with helium. Anyway, yeah, the more common way to do this is to have a fuel pump, which will take the fuel from the tank at relatively low pressure and then pressurize it and push it into the engine. So the high pressure area is only around the fuel pump, and you don't need super heavy tanks. So the typical type of pumps used are something called turbo pumps. These kind of use spiral structures, which look like kind of weird alien mollusk shells. I don't know, they look really cool when you see them the way they work. Now, these are actually used in fire engines as well. But you know, how do you drive these is really the next question, because you need a lot of power to drive this to get the fuel to come through it as quickly as possible. And actually, if you look at an in-development rocket, a small rocket called the Electron, its engine is called the Rutherford engine, and that is rather unique because the fuel pumps in that are powered by electric motors, 50 horsepower electric motors driven by batteries, and they will take the fuel and push it through into the engine at high enough rates. Similarly, kind of more unconventionally, you might have heard of the Bloodhound, which is a car that's being developed that will supposedly go 1,000 miles an hour. Now, it obviously has jet engines, and it has a rocket engine, but you may not know that the rocket engine actually has its fuel pumps driven by a regular internal combustion car engine, right? Because they need to pump the fuel into the peroxide fuel into their rocket chamber, combustion chamber.
Whoa. This rocket car has a internal combustion engine car engine to drive its turbo pumps. Wow. Anyway, so yeah, this is Scott Manley. If you don't know who he is, if you want to learn how to play Kerbal, Scott Manley is your guy. He's a boss. He's a really cool guy. You know, I think that there's been some nods to Scott Manley. I think there's like a monument on the moon. Yeah. He ends all of his videos with "fly safe." I think there's a monument on the moon that says "fly safe" or something like that on it. Anyway. Yeah, so that's liquid rocket engines. Did I get out of that? Gosh dang it. Sorry. Forgot that. Okay. So, yeah. We know about solid rocket fuels, right? You light them and they go boom, and then they don't go boom. You can't really throttle them. Most of the time they're used for like boosters, side boosters. They have a really high thrust to weight ratio. What's the thrust to weight ratio?
The less weight comes out, the higher you're able to have a higher velocity.
Right. So if you have high thrust and low weight, you're going to go really fast, right? If you have a high weight and low thrust, you're not going to go very fast, right? Solid rocket motors are very high thrust to weight ratio. They provide a lot of oomph. Okay. The classic example is the space shuttle, but there's also solid rocket boosters on the Ariane 5. Right here. So if we check this out, this guy. So this is a liquid rocket motor right here, just a single one on the core stage, and then it has two solid rocket boosters on the sides. And solid rocket boosters are nice because you just light them and they go, right? It's really oversaturated in the projector, but pretty cool. Very, very powerful, these side boosters. Most of the time, if you use like a bottle, if you use like a bottle rocket or a amateur, use an amateur rocket bottle rocket, whatever, it's going to use a solid rocket motor. And you'll notice that it goes real fast. Okay, just goes straight up. Even a small little motor can get a rocket really moving. So yeah, solid rocket boosters. I don't need to talk too much about those. You can use different chemistries for solid rocket boosters. Most of the time they use, like you can use like black powder, you can use potassium nitrate, you can use potassium chlorate, you can use all sorts of different stuff. Aluminum oxide, you can use all sorts of stuff. Yeah.
You just get a feel for how powerful these are. They're going to have solid rocket boosters that, okay, but this being big enough to like how force feet, like ours, they kind of have to brace for ignite it. How much thrust?
If your water bottle was a solid rocket booster, it would be powerful enough not to just push you back, but probably rip your arm off.
Okay.
Yeah.
If I were to place it up against the wall and light it, would it go through the wall?
Depends on if there was a stud behind it or not.
It might can.
It would definitely go through drywall. It would probably go through most hardwood.
What if I can?
If that was,
If this was a feeling, would it go like right through my hand?
well, not to start. It would need to get a head start, but it could.
Oh, but if it was like right here. Then,
Yeah. It would definitely go into your hand. I don't know if it would go straight through. But yeah, like the biggest, let's see here. Type N. Rocket engine.
What about if I was a rocket fuel?
If you were a
What does that even mean?
so you can use You can use solid rocket, little ones, little. Oh no, that's not what I wanted. Not model train, model rocket engine. So you can get all sorts of different sizes. They're pretty small. So the ones that we use for Rocketry Club are these guys right here, the F-32s.
Why would we use the G-78?
If you want to go faster and higher.
Yeah.
Oh, that's a little model
Can
rocket.
we carry bigger rockets with us? Obviously, we couldn't, right?
Oh yeah.
Those
But
things are cool.
these guys, there's some amateur rocket, like model rocket builders that build. So C, A is the smallest, then like essentially just a bottle rocket. And then B, and then C, and then D, right? And then E, and then F, G. There are some that you can buy that are L all the way through N. And they're like,
At that point, when does the military come?
you have to have a license to launch anything above a G.
At what point
Really?
do you just have,
Uh-huh.
at what point do you just use your rocket launcher? Like,
Aiden,
Solid rocket booster.
did you turn the entirety of the what?
Inside the air. Into a giant rocket.
uh,
Solid fuel rocket. How fast did it go? Your
fast. I don't know about the calculations, but it would be fast. Okay. So now this is going to be all that we can cover today, but we need to talk about hybrid engines. So we've talked about solid, we've talked about liquid. What do you think a hybrid would be? Yep. A hybrid rocket engine
oh, wouldn't I guess it's solid?
uses solid fuel with liquid oxidizer.
What did I
Huh?
Just solid fuel? What did I mean? Or
No,
no?
you're good. Okay. So you have fuel grain, so something like you can use a lot of, so at Utah State they have a lab that does a bunch of tests on this kind of rocket engine. They use plastic as the fuel. They use a plastic as a fuel, and then they flow oxygen through the fuel. And there's the igniter right here, just like a spark plug. So advantages of this: it's lighter than a liquid fuel engine. It is throttleable. You can control how much thrust you get out of it because you can open the valve or close the valve. You can restart it. Okay.
You don't have to worry about the fuel grain catching flame on itself.
Yep. The fuel grain cannot catch flame on its own because there's no oxygen for it. Okay. So looks like that. Okay. So this is a really simple setup. You also generally don't need any turbo pumps for this. You can just have like a high pressure helium back here that pushes the oxidizer through here into the fuel grain. And then, yeah, they're pretty cool. They're a pretty cool design. You can get all sorts of interesting things out of it. however, even though this is a very cool design, it is extremely rare. Almost no rockets use hybrid engines. I don't know. I think that a big part of it is just that there hasn't been a lot of research into this stuff. It's generally been, well, liquids are the things that we know really work, so we're going to use them. And if our liquid rocket engine is too heavy, then we'll just strap some solids on the side and it'll go boom.
We're using the Soviet approach to things. If it ain't broke,
If it ain't broke, don't fix it. The only major hybrid rocket engine that I know of is on the Virgin Galactic Spaceship 2. And this is what it looks like right here. So this is a hybrid rocket engine right here on a space tourism space plane.
with a ticket price of $5 billion.
Ticket price of $250,000.
I could make that up in 5 years.
That's like a house.
Yeah, it's about as expensive as a small house in Utah, but still a house.
So you can either be homeless, but have gone to space.
So this is what it looks like when it's firing its engine. I think the Spaceship 2 is a very, very pretty looking spacecraft. Fun fact, it also uses air launch. This is the White Knight, a 4-engine double fuselage airplane that carries the Spaceship 2 up to 20,000, 30,000 feet, something like that. Lets it drop off, and then Spaceship 2 rockets up into space using its hybrid engine.
We've come a long way since the Wright brothers.
Yes, we have. So pretty cool. Okay, so those are the 3 major types of chemical rocket engines. I'm going to leave it at that today. Like and subscribe or whatever.